Good afternoon, students. So today we are going to learn about what is the normalization of a wave function. So normalization of a wave function, this concept is related to the probability. Okay. So first of all, this is your psi. Okay, psi is your wave function. So the if a particle found in a certain region, then probability of that finding that particle in that region is given by psi into the psi star. Okay. So what is psi into psi star? Psi into psi star gives you the probability of finding the particle in that particular region. So if particle is located in that particular region, then its probability is equals to 1. That's why what is the probability? Psi into psi star, this value should equals to 1. So you can write this equation in terms of integration. So finding that is integration from minus infinity to plus infinity, that means all space. Probability density PR into volume, small volume means dV is equals to 1. So that means if I take the integration of a wave function, what is probability? Psi into psi star. And small volume means x, y and z. So that's why dx, dy and dz. So this is in 3-dimension case. So if wave function is a normalized wave function, then its integration over all space psi into psi star dx, dy, dz, this value should equals to 1. That means उस particle को उस region में रहना ही पड़ेगा from माइनस इन्फिनिटी टू प्लस इन्फिनिटी, फिर उस रीजन में रहेगा तो उसका प्रोबेबिलिटी कितना रहेगा 1. सो दैट्स व्हाई व्हाट इज मीन बाय नॉर्मलाइज्ड वेव फंक्शन? फॉर नॉर्मलाइज्ड वेव फंक्शन, इफ यू टेक इट्स प्रोबेबिलिटी डेंसिटी ओवर ऑल स्पेस, दिस वैल्यू शुड इक्वल्स टू 1. एंड इफ psi satisfied this condition, then that wave function is known as your normalized wave function. Okay. So this is the case for 3 dimension. If I have to take the condition for 1 dimension, then I can say that its integration from over the region x psi into psi star dx is equals to 1. You can take it as from minus infinity to plus infinity. Okay. So it is the value of psi in only x region. If I have to take in 3 dimension, I have to take for all space. All space means I have to take along x axis, y axis and z axis, and probability. Probability means psi into psi star, here dx, dy and dz. This integration value should equals to 1. If this value is equals to 1, then that wave function psi is known as your normalized wave function. And what is this psi star? Psi star is known as the complex conjugate of a psi. That means if I take psi is equals to e raised to the power ikx. Suppose this is the value of psi. Then what is the value of psi star? Psi star is equals to e raised to the power minus ikx. That means the imaginary term here it is positive, and in conjugate here it will be changed to negative. That is the difference between psi and psi star. That is known as psi and psi conjugate. Okay. So what is normalization of wave function? Normalized wave function, its integration from minus infinity to plus infinity, and probability psi star into psi, and region. If it is 1 dimension, here dx. If it is 3 dimension, here dx, dy and dz. You can replace dx, dy and dz with the dv also. Okay, that is small volume. This value should equals to 1. Okay, so this is about your normalized wave function. But what you can do if wave function is not normalized? Then we have to make it normalized wave function. Okay, suppose you have given the wave function psi, and if you take its integration psi star psi and it is not equal to 1, then at that time you have to make that wave function into the normalized wave function. So what is the procedure of normalization? Okay, so you can say that what is the procedure of normalization? Procedure of normalization. Procedure of normalization. How to make a wave function normalization. Suppose psi is a wave function, okay, and psi is your wave function. And what is psi star? Psi star is a complex conjugate. Psi star is your complex conjugate of wave function psi. Okay. Then their integration from which region? From minus infinity to plus infinity, psi into psi star into dv. dv means it is in the small region x, y and z. This value should equals to 1. If this is not equals to 1, then what we have to do is we have to multiply with a on both sides. Okay, a on both sides means you have to multiply psi with the a. That means multiply or take psi is equals to a psi and psi star is equals to a into the psi star. Multiply a with the wave function psi and substitute here. Okay. A is your normalization constant. What is A here? A is a normalization constant. Now, if you substitute psi with a psi and psi star with the a psi star, what is this? Psi conjugate. Psi conjugate with the a psi star. How the equation will be? This will be integration from minus infinity to plus infinity a into psi. This will be a into the psi conjugate into dv is equals to 1. So this a into a, this will equals to minus infinity to plus infinity mod of a square psi into psi star dv is equals to 1. So this value, what is the value of a square? This value will be 1 upon integration of minus infinity to plus infinity psi into psi star dv. Okay, if you substitute, if you solve this value of psi for minus infinity to plus infinity, you will get this value a square. From a square you have to calculate a, and this normalization constant you have to take with the psi. Then what happens? Then a psi is your normalized wave function. Which is your normalized wave function? So a into the psi is a normalized wave function. And what is a here? A is your normalization constant. This is the case for 3 dimension because you have taken volume. Volume means dx, dy and dz. Here there are 3 integrations are there. If I have to take for 1 dimension, then this normalization constant you can write a square is equals to 1 upon integration over the region x. Okay, because you have to take it for 1 dimension. If I have to take it for 1 dimension, then this will be equals to the psi into psi star into dx. Here it is complex conjugate from region minus infinity to plus infinity. So this will give you the value of normalization constant for 1 dimension. If I have to take the 3 dimension, I will differentiate with x, y and z also. Here if it is one dimension means it is along which axis? X axis. Then I can write the normalization constant is equals to this. If it is in y axis, I have to replace dx with the dy. So this is the procedure for your normalization of a wave function. Okay. Here we will take the problem on how to do the normalization of a wave function in next lecture.